The fact that exponential functions are one-to-one means that if we see two exponential functions set equal to each other with the same base, that also means that the exponents have to be the same. So in this case, x minus 4 equals 2x plus 1. And now we have a simple linear equation to solve to figure out what x is. We can just subtract x from both sides and subtract 1 from both sides, giving us that negative 5 is equal to x. And if we go back and plug it in, we would have negative 5 minus 4 is negative 9. So we would have 3 to the negative 9 on the left side. And then 2 times negative 5 is negative 10 plus 1 is negative 9. So we would also have 3 to the negative 9 on the right side. So we have equal expressions. So the trick in solving an exponential equation is to get the two bases on both sides of the equal sign to be the same, just as the 3's are here, so that you can then set the exponents equal to one another. So for example 2, we're dealing with bases of a 2 and an 8. So we want to think about how can we make an 8 look like a 2 or a 2 look like an 8 by using exponents. Well, 8 is the same as 2 cubed. So what we want to do here is we want to rewrite this right side as 2 to the third in place of that 8, and then that is raised to the x plus 4. And then thinking back to all of the rules that we learned about exponents, when we raise an exponent to another exponent, we multiply those exponents together. So in other words, the right side is the same as 2 to the 3 times x plus 3 times 4, or 12. And now that we have that common base of 2 on both sides of the equal sign, we can set the two exponents equal to one another. And again, we're back to solving just a simple linear equation. Subtract 3x from both sides and divide both sides by negative 4, and we end up with x equals negative 3. So for example 3, the question is, how can we make a 4 look like a 1/4 or vice versa? Well, 1/4 is the same as 4 to the negative 1. And that's still raised to the 6th power. And I'm just going to bring the 4 to the x squared minus 5x down as is. And then again, on this right side, we're raising an exponent to another exponent, so we can multiply and turn that into 4 to the negative 6. And now both sides have that base of 4, so I can set the exponents equal to one another. X squared minus 5x is equal to negative 6. And now in this case, I have a quadratic equation to solve, which means I want to get it set equal to 0. I'm going to add this 6 to both sides, giving me x squared minus 5x plus 6 equals 0. And then this factors as x minus 2 times x minus 3. And then setting each factor equal to 0 would give us x equals 2 and x equals 3. For example 4, the thing that we need to recognize here is that both 27 and 81 are powers of 3. 3 is going to be our common base. 27 is the same as 3 cubed, so that's raised to the x plus 2. And 81 is the same as 3 to the 4th, and that's raised to the x minus 1. And then again, I'm going to multiply my exponents so that the left side becomes 3 to the 3x plus 6, and the right side becomes 3 to the 4x minus 4. And then since I have the same base of 3 on both sides, I can set the exponents equal to one another. 3x plus 6 equals 4x minus 4. Then I just need to get my x's on the same side and my numbers on the same side, and I end up with 10 is equal to x. So for example 5, the question is, how can I make a 2 look like a 1/4, or vice versa? Well, remember we said that 1/4 is the same as 4 to the negative 1. So multiplying exponents means that this right side is the same as 4 to the negative x. And then 4 is the same as 2 squared. And again, multiplying exponents gives us 2 to the negative 2x on the right side. And now both sides of the equal sign have that common base of 2. So I can set my exponents equal to one another and say x minus 9 is equal to negative 2x, and then get my x's together and divide by negative 3 gives us x is equal to 3.